Assalamualaikum and hi, we are Team KitaHack. Today, we are presenting SediaBanjir, your guide to stay one step dry. SediaBanjir is a web-based flood preparedness platform aligned with SDG 11, Sustainable Cities and Communities, and SDG 13, Climate Action. Our mission is to help Malaysians better understand flood risk and prepare effectively through AI-powered guidance. This is our team members. We have Nurul Jana binti Karul Azman, Christina Balkis binti Abdulaziz, and Fina Alfiani binti Nur Fauzi.
Floods in Malaysia are becoming more frequent and severe, directly affecting communities across the country. For example, Malay Mail recently reported that in Sabah, hundreds of people were forced to evacuate due to continuous heavy rainfall. This isn't just an isolated event. Flood caused widespread damage to homes, infrastructure, and livelihood every year. The problem matters because without timely, accessible information, people can't prepare effectively, putting life and property at risk. SediaBanjir addresses this by providing AI-powered flood advisories, location-based risk assessment, and detailed flood risk analysis to help Malaysians stay safe and make informed decisions before, during, and after floods.
In SediaBanjir, we integrate both Google AI and Google Developer technologies to ensure intelligence and scalability. For our Google AI technology, we use the Gemini API via Google AI Studio. Gemini processes structured prompts generated by our backend and produces dynamic flood risk explanations, safety recommendations, and preparation guidance. This allows the system to deliver context-aware insights instead of static predefined messages. For our Google Developer technology, we use Firebase authentication, which ensures security, user management, and reliable access control. Firebase provides a scalable infrastructure layer that supports secure deployment and integration. By combining Gemini's AI capabilities with Firebase's developer infrastructure, SediaBanjir delivers intelligent, secure, and scalable flood advisory services.
So now we will demonstrating the SediaBanjir. First, when the user visits the platform, they are prompted to sign in securely using Google Authentication. Once signed in, the dashboard greets the user by name and presents a clean, intuitive interface. At the center of the page is a flood monitoring map, which visually represents a flood risk condition across selected areas. Below the map, the user selects a state and district using drop-down menus. And for this demo, imagine I am a resident in Johor, specifically in Johor Bahru, living in Nusa Dutta. So I select the Johor as the state and choose the relevant district and click Check Risk. So behind the scene, the system sends a request to the backend API, which evaluates a real-time simulated hydrological data. So within seconds, the system returns a risk classification, for example, normal, alert, warning, or danger. So in this case, the system retrieved data from the station at Kolam Air in Nusa Dutta. So the results show a normal risk level with a score of 21 out of 100. So the water level is 0.89 meters, which is well below the 3-meter danger threshold. There are no active thunderstorms and the trends show no change. Now what's important here is that AI immediately generates a clear advisory. It explains that while there is no immediate threat, residents should continue monitoring updates from authorities like JPS and NATMA to encouraging to be vigilant. Now let's move to a more serious case. Let's say I switch the state to Sarawak, select Miri and check the risk for Long Teru. So the system reports a danger level with a risk score of 90 out of 100. So the water level is 8.31 meters, exceeding the 8-meter threshold, and most importantly, it's still rising. So immediately, the interface reflects the severity. So the AI advisory shift tone. It now provides urgent, step-by-step safety instructions. It advises residents to prepare evacuation, gather emergency kits, disconnect utilities if safe, and move valuables to a higher ground. So it clearly wants residents in low-lying areas to be ready to evacuate immediately and to follow instructions from APM, Bomba, or local authorities. So the system doesn't just detect danger, it interprets it. It transforms technical hydrological data into actionable, human-centered guidance. Besides that, the platform also supports bilingual output, allowing devices to generate it in English or Bahasa Malaysia, increasing accessibility for local communities. So that is the strength of SediaBanjir, by combining real monitoring data, dynamic visualization, and AI-powered advisory into one seamless decision support system for Malaysian communities.
We conducted pilot usability testing with 3 participants to evaluate clarity, usability, and prediction understanding. All participants rated overall satisfaction 4 out of 5. Preparedness, helpfulness, and satisfaction received the highest average ratings of 4.7 out of 5. Based on user feedback, we implemented 3 improvements. First, we restricted the map scope to Malaysia. Second, we replaced manual text input with drop-down menus to eliminate invalid entries. Third, we added bilingual support to improve accessibility. These improvements enhance platform reliability, user experience, and inclusivity.